So the Facet Grid is one of another kind of plot. Okay, I will just directly use this Facet Grid because in the previous one we just use the plot. Okay, the common plot from the matplotlib. Actually, we can use SNS. SNS is the library of Seaborn. Okay, we use the Seaborn, and there is one function, Facet Grid, and the function is similar with the scatter plot. And if you can see here, the Facet Grid is using the data of iris. Who means the label. So if you have any label that you want to specify, you can specify in the hue. And then the size is about the size of the graph. And you want to map. What is the map? Yeah, it depends on the type of your plot. So in this case, I'm still using the PLT. PLT is from the matplotlib. So it is a combination between the matplotlib and the Seaborn. And we have the scatter plot. What we are going to plot is the sepal length and the petal length. And then at the end, I want to add the legend. So this is the legend. Okay. Using this kind of plot, we can combine from the Seaborn and the matplotlib. There are many other Facet Grid. Yeah, that's right. Facet Grid is another kind of plot. Okay, it is based on the Seaborn. So you can take a look on many other kind of plot with Seaborn, but due to the time limitation, if you want to see other plot, you can take a look on the library of the Seaborn. Okay, pie plot. Okay, if we want to show the pie plot, it means we are going to check the categorical attribute. Okay, so first we can calculate how many, okay, how many of the Virginica, Setosa, and versicolor. After we know how many of Virginica, which is 50, Setosa 50, and versicolor 50, then yeah, you can make the plot. Okay. So if I combine everything into one statement, so I use iris and I use this the categorical data. Okay. This is the categorical, only for the categorical data. Okay. And yeah, we calculate the value, or we calculate how many of the categorical data, and then we use the plot and pi to draw it. So we have Setosa, Virginica, and versicolor in the pie plot. Okay. So this kind of visualization can be in any kind of data set. Okay. So I will use the second data set, which is tips data set. So in the tips data set, it is related to tips given to a restaurant with attributes as follows. So we have total bill. Total bill is the amount of bill paid by the customer. So if you visit restaurant, you will have the bill, 영수증. Okay. So how much you pay for the restaurant. Tip. In USA, you need to give the tip for the waiter. Okay. It depends on the number of bills, and it depends on the number of customers they serve. Okay. So if you go to restaurant with your family, maybe if you're 4 members, then maybe you need to pay more tips. Okay. So the amount of tips will be vary or will be different from one customer to another customer. Sex, gender. So in this case, I think the gender is about the person who give the who participate on the survey. Smoker, whether they are smoker or not, they what day they visit to the restaurant. So there are 4 kind of days: Sunday, Saturday, Friday, and Thursday. And then the time. What is the time they visit restaurant? So whether it is dinner time or lunch time. And then the size is the number of a company. So if the company is 2, it means they are only 2%. If the company is 4, then they are 4%. Okay. So using this data, we can use the tips data set in the SNS or Seaborn. Okay. And yeah, you can take a look. This is the data: total bill, tip, sex, smoker, day, time, and size. Okay. So please allow me to a little bit speed up this session. Okay. So the tip sum by day. So I will use very simple group by. Okay. What does it mean by group by? So I want to group the data by the day. So the day, as you know, we have 4 days: Thursday, Friday, Saturday, and Sunday. And then I want to know the tip. The tip is the amount of tip that every customer pay. And I would like to do the summation. So I want to know how much tips the restaurant get on Thursday, how much tip the restaurant got on Friday, how much tip the restaurant got on Saturday, and how much tip the restaurant got on Sunday. And you can see that the amount of tips on Saturday is the highest one based on this number. Okay. Now, you can, okay, let me run this. And you can see this kind of label. Okay. So I think this is related with the question of one student, or Kang Hyunu. When you ask about the label, whether you can use the index. Yeah. So this is one way. Okay. When you create the label with list like this one, or you create a column with list like this one, then you can make your index. Okay. So let's say I have the Thursday, Friday, Saturday, and Sunday with this kind of label, and then the index will be a number. I hope that you still remember with the arrange. Okay, arrange is a kind of number, and I want to make a number until the length of the label. So if we have 4, then this is a number of 0, 1, 2, 3. Okay. So if I run this one, I do the index. So you can have 0, 1, 2, 3. And yeah, we can do the bar chart. So this is a more complex way to define the visualization, not directly from the data, but you need to pre-process the data first before you do the visualization. In this case, I want to plot the bar index. Index means 0, 1, 2, 3, which is about the Thursday, Friday, Saturday, and Sunday. And what I want to set the Y is the tip sum by day. So how much tips that I got. We can use plt.bar. So this is the plot. Okay. And you can put all the parameters. Now you can see here it's a little bit different with the IRIS data set. In the IRIS data set, you need to specify based on the data variable, which is iris. Okay. So everything you can start with iris dot something, iris dot something, iris dot something. But in this example, I show you another way to do the plotting by calling PLT. Okay. So you can use the plot with PLT. You can use the PLT dot bar, PLT dot line, PLT dot box. Okay, so that's also available with that one. Okay, but I just want to show you with the bar chart at this moment. And you need to specify the parameter like the title, and you can set the size of the font, and then the X label, the Y label. Okay, you can set also the font size, and then the X ticks. Okay, so what is the X ticks? Yeah, this one. X ticks. Okay, and then here you want to set this X ticks the index. Okay, so the index is from the 0, 1, 2, 3, and you want to show it in the label, and the label is the Thursday, Friday, Saturday, and Sunday. So the result should be shown. So you need to use the plt.show. Yeah, you can see if you use the plt, you need to set all the things before you show it. Okay? Show is the last or the final statement to show this graph. Let's say if you want to make the summary by group. Okay? So I will explain more about the group by in a separate section, but now let's say I want to see whether the male give more tips than female. Okay, yeah, this is only just for checking. Okay, I want to check the condition. Okay, I guess by now you already know how to make the condition. So if the sex equal to male, so I would like to group by the day. So it's the same with the previous one. And then I want to group the tip, and I want to group by the sum. So I would like to sum based on the sex equal to male, and I want to sum based on the day. The same with the other one, but it depends on the data where the sex equal to female, which is the day, and then we will do the summation on the tip. Okay. Oh, sorry, I need to run this one. And yeah, if I want to show the tip sum by the male, this is from the male, and this is from female. Okay, it seems male give more tips than female. But yeah, if you see this number, it seems a little bit difficult to clearly understand the numbers. So you can use the visualization. It is more complex because yeah, in this kind of visualization, you need to define what you want to show to the reader. So in this case, I define the label, which is Thursday, Friday, Saturday, and Sunday. Yes, this is the same. And then I have n. Yeah, I would like to. Yeah, it's actually this is the same with the label. Okay, length label is the same with tips date dot unique. You know unique. Unique. So you want to find only the unique nominal data. So if there are Thursday, okay, if there are many Thursday, then you will just put only one. Okay, so we want to get the unique value. And then yeah, we have the index. Alpha is about the transparency, so I will let you know later. So we have P1. Let's say this is the bar chart using the index, and then I would like to use the male data, and the color let be blue. And then the alpha is 0.5. It is to show the transparency. So it's a little bit not the blue, but it's a little bit like light blue. Okay. So you can see this color is a little bit transparent. Okay, transparent. So P2 is the data from female, and the color is red, using the same alpha, and put the female at the bottom of the male. So this is the stack bar chart. And yeah, you can define the other like this one. The title, the Y, and the X are the same. The ticks also are the same. The legend. Okay, now we have two legend. The first legend is male, and the second legend is female. Okay, so we define the legend, male and female, this one, and finally we will show it. Okay, so this is the result. Okay, now if you want to show a little bit tidy, it means if this one is the stack bar, yeah, one is in the bottom and the other is in the top. But usually people would like to use this kind of bar chart. One is on the left, the other is on the right. You can use the same idea with the first one. We have that define the bar width. So we can define the width of the bar. The alpha, yeah, you can define any number. Let's say this is 0.5. And I use P1 and P2, same. But in this case, we have the index, and the index will be plus with the bar width. So we have some space. Okay. We have the color, we have the alpha, and then we have the label. Okay. We have the color, alpha, and the label, and the remaining are the same. Okay. And then finally we just show it. Then don't forget, if you have this one bar width, because we have two different bar. The first bar is for the male and the second bar is for the female. So we need to fit with the size of the graph. That's why we have the bar width equals to 0.35 in order to match with the size of this graph. Okay, and yeah, the other things is just an additional bar plot. You can use the seaborn. Okay, so if you use the bar plot with the seaborn, it means you can just use SNS dot bar plot, and then you define the X. What is the X? Let's say I want to plot the total bill, and then I want to plot the Y equals to day. So the Y equals to day, and then this is from the data tips, and then the estimator sum. So we would like to sum all the total bill. CI, so this is the another parameter, so just make it known so we cannot see the result. And then the color, so the color, yeah, you can define any color. So in this case I use the hexa number for showing the color. Okay, basically, yeah, you can change this into red, blue, green, and etc. Yeah, this is the same, but it is in the vertical. Okay, we have the Y is the total bill, and the X is the day. Okay, so we just change the X and Y, and the format will be different, but the remaining are the same. We use the data tips, we have the estimator sum. So CI, I will skip this one, and the color is the same. Okay, so I think there are many things we can learn from the basic visualization, but you already see some basic of them. And now I would like to show you more charts, and charts that you will learn is a little bit more complex than the previous one that we learned. So this chart, so I will use NumPy and pandas for the first, and then I will use Seaborn to get the data set. Oh. And I'm using the IRIS data for this visualization. And don't forget to use the matplotlib for the visualization. Okay. Now for this section, I will teach you how to use the simple Seaborn. So you already see some of the Seaborn statement and some more comprehensive chart like join plot, pair plot, and box plot for the overview, LM plot, and heat map. Okay, so I hope that I can finish all these things today, so we can do with the practice. Actually, it's not practice, but it's assignment. Okay. Okay, join plot. So join plot is one of the function in the SNS. As you know, the SNS is not the social media. Okay, so this SNS is the Seaborn library. Okay, so in the Seaborn library, we have the function of several complex visualization. We call it, this is join plot. In the join plot, we need to specify X and Y. So it's similar with the scatter plot, but it includes the histogram. Okay. So we have the X. What is the X? Is the sepal length, and then the Y is the sepal width. Okay. And yeah, you can see this one. This is from the data IRIS. So this above chart explain the distribution of two attributes, sepal length and sepal width, including the scatter plot. So it combines the scatter plot and the distribution. In this join plot, you can see more clear explanation. Okay? So you can put kind equals to rec. Rec means regression. So you can see here, this is the regression line. So if you want to do regression, then this is the regression line. And then if you want to see the distribution, yeah, you can see like this one. Okay, the sepal length, it seems normal distribution, because in the normal distribution, the plot will be something like this one. Okay. And also the sepal width, yeah, it seems like this is also a normal distribution. Okay. So using with regression, you can see this join plot. So the above chart explained the same with the previous chart. Additionally, it shows the regression or linear to show how the data correlate each other. We can have another kind of join plot. So you can change the kind. Okay. There are many types of kind, but I cannot explain all those things. Let's just see some examples. In this case, I use hex. Okay. So if you still remember hex, okay, in the first part, you can see, yeah, there are some explanation with this matplotlib. Actually, some of them can be also adapted to the Seaborn. Okay. So here we use the hex. It is the hexa. What is this? The hex pin. Okay, hexagonal. Okay, because this is hexagonal pin or hexaplot. So you can see the hexagonal, and then yeah, the dark color means the higher one or the more dense, than the white one. So the white is not so many data in that area. Okay, so the color with the dark color, it shows, so it is represented in the form of hexagonal, and show that the dark color is more dense than the bright or white color. If you use the KDE, this is kernel density estimation, okay? Kernel density estimation, then yeah, some of the chart may use this one. This is the distribution, this is the distribution, and we can see that the density is more here. Yeah. But this is more advanced approach for the visualization. Okay, we use the probability density as the continuous variable. So oops. Okay, so actually the above chart explained the same with the previous chart, but we have like different color. Okay, so we have the different color from the other chart with what we saw on the previous session. And yeah, we can also use this kind of box plot. So this is the overview. Okay, why we can say it is an overview? Because we can group based on the species. Okay. I use the iris data. Now I don't use the NSS. I don't use the SNS. I return back to this iris, and I want to check the box plot with regard to the other attributes. So here we have the species. Okay. So I can get the length, petal length, and then this is the setosa. This is the versicolor, and this is the virginica. And I can say that, okay, the petal length of setosa, it seems small. The petal length of the virginica, it seems high. Okay. The sepal width for those three colors are similar. Okay, we can see from this box plot. From the other attribute like petal width, yeah, you can see also this virginica is high for the petal width and low for the petal width. For this data, also sepal length, yeah, it shows that the virginica is higher than setosa. So from this data plot, you can see that virginica seems a bigger flower than setosa. Okay. But virginica and versicolor, it seems a little bit similar, like this one similar, yeah, this one similar, and this one is similar, and yeah, this one is also similar. Okay. Those kind of analysis will be good, okay, if you see like this kind of plot. Okay, so I guess you already know the box plot. So it is based on a 5-number summary. What is 5-number summary? Yeah, we have 5 items: minimum, Q1, median, Q2, and maximum. And we can see with respect to each species type. So we have petal length, petal width, sepal length, sepal width for each species. Okay. So we can say that the petal length and the petal width are attributes that can distinguish the species. So yeah, you can see later. Yeah, petal length and petal width is, yeah, you can see the difference of the data between the species, and those attributes is the attribute that may useful for classification. The other kind of plot, we call it pair plot. So this pair plot is similar with the other kind of plot, and we want to see all those numerical attributes with respect to the categorical attributes, and we want to plot it for all. Okay. So sepal length and the sepal length, yeah, sepal width, petal length, and petal width and petal width. So you can see all the plot at the same time. So here is petal width and sepal length. Here is the petal length and the sepal length. Okay. So you don't need to plot one by one. So you can just use pair plot, and you can see all at the same time. And if you use the who species, you will distinguish the data based on the color green, which is virginica, orange is versicolor, and blue is setosa. So you can easily see that, okay, the blue, and okay, all the blue seems very different than the orange and the green. Okay. So the setosa flower seems very small. Yeah, if you can see, it's in the left most of the time. Yeah, you can easily get insight from this kind of plot or pair plot. So it is to show the overview of the distribution of every two attributes. Then if you have many attributes, yeah, you can put it on directly in this kind of visualization. Okay, and then yeah, you can do the analysis directly. Heat map. In the heat map, we can also show the correlation of the data, but it is not in the plot, or it is not in the scatter plot, but it is more about the correlation. Okay, so the correlation between the attribute, we can see something like yeah, of course, if the sepal length and the sepal length, there is no correlation. Okay, this is no correlation, no correlation, no correlation. Okay. But what about this? Yeah. What about this? Okay, a dark color. So it seems the dark color is showing the negative. Okay, so it's more negative correlation. Okay. So if it is bright color, yeah, it shows a positive correlation, more positive. So petal length and sepal length. Okay. The sepal length and petal length. Okay, so it seems here is more correlated. Okay. So petal length and petal width. Okay, it is bright color. So the correlation between petal length and petal width is high compared to the other correlation of data. It shows the correlation between two attributes on all numerical attributes. So if your data contains numerical attributes, you can use this. But if your data is categorical attribute, you cannot use this directly. Okay. So the darker color represent the higher correlation in comparison to the other attributes. Okay. You can also show the overview of histogram. Okay. So here, if you use the iris.hist directly, you can see the sepal length, sepal width, petal length, and petal width with respect to all the data. Okay, so this is the distribution. And yeah, the histogram shows the distribution of all numerical attributes in respect to the frequency of the instance in the particular bin. If you still remember the bin, so this is using the default bin, which is 10. Okay. And we can also use another kind of plot, which is LM plot. Yeah, basically the LM plot is the subplot of the joint plot. If you still remember, we use the joint plot. And then when you have the parameter, one of the parameter is kind, then you can put the rect. Okay. When you put this rect, it means it will show the regression plot. So the regression plot is same with the linear plot or LM plot. Okay. So this LM plot, it shows this line. Okay, this is the linear line. So this is like negative correlation. Okay. The scatter plot follows the linear plot to see the correlation between two attributes. So in this case, we have the sepal length and the sepal width. And yeah, the other things that I want to explain is about this facet grid. Yeah, so I explained to you in the previous one. We have the facet grid to show a kind of the scatter, or yeah, we can show also the histogram. Yeah, in this case, I would like to show the KDE plot. So you can define later what kind of plot you want to show. Yeah, there are many things that we learned today. In this case, I use the KDE plot. This is kernel density estimation plot. And based on the iris data, and let's distinguish based on the species. Blue color is the setosa, orange is the versicolor, and green is the virginica. And then I would like to use the kernel density estimation plot for the petal length and add the legend. So the petal length shows that in between 1 until 2, this is using the kernel density estimation based on the probability density function. So there are many data in between this range. And then for the versicolor, the probability is about here. And then the virginica, the probability is about here. So it means the setosa, most probably they are small. Okay, the Facet Grid is another type of histogram with the color base of KDE, kernel density estimation. So you can use Facet Grid, but there are many types of the Facet Grid. One of them is the histogram. Okay, I guess I already finished with this visualization with the complex one and the basic one. Okay, so I would like to show you about the practice. Okay.